Hello everyone. What we'd like to do in this video is see how we can use the law of sines to solve a SAA or an ASA triangle. Now while in this video I'll specifically be focusing on these types of triangles, usually ahead of time when I'm ever given a problem or a certain triangle I'm trying to solve, I usually don't remember, SAA, that's a law of sines problem, or ASA, that's a law of sines problem. Usually I draw the picture of the problem and I think to myself, should I be using the law of sines? Should I be using the law of cosines? I try not to memorize too much, but specifically we just want to know if we're ever in a situation where essentially we know two angles of the triangle, we can use the law of sines to find the rest of the information. So let's recall what the law of sines says. So given any triangle, so this is angle A, this is angle B, and this is angle C. This would be side length A, this would be side length B, this would be side length C. What we discovered is that if we take the ratio of the sine of an angle over its opposite side, that'll be equal to the ratio of the sine of another angle over its opposite side, which will be equal to the sine of the third angle over its opposite side. This is what the law of sines says. Or sometimes, depending if I'm looking for an angle or a side, you could reciprocate this whole formula. We could say, or the law of sines also says that A over sine of angle A is equal to B over the sine of angle B, which will be equal to C over the sine of angle C. And you'll see with the more examples that we do, you'll hopefully get a feeling for which of these versions is more useful to work with. Okay, so let's do some examples. Okay, let's say our first example, let's say we're given that angle A is 37.5 degrees. We know that angle B is 28.1 degrees. And we know that side length A is 17. Okay, our job is to find the other two side lengths and the third angle. Now what's great about knowing two angles of a triangle is I can easily find the third. And that's what's going to be really nice about the problems in this specific video. We'll know two of the angles. Okay, so what I always like to do is I try to draw these triangles. You don't have to, you don't have to be drawing these triangles to scale. You can kind of algebraically go through these. I try my hardest to draw a triangle that's roughly to scale to get a feel for what's going on. Okay, so angle A here, I'm going to notice that this is an acute angle. It's less than 90 degrees. Okay, so in this case here, this is 37.5 degrees. This is angle A. Okay, we know angle B is also acute. So I know that this angle here, this is B, this is 28.1 degrees. And we know side length A. So we know that this length right here is 17. Okay. What we need to still find on this triangle is we still need to figure out the third angle C. We need to figure out side length C, and we need to figure out side length B. So this is our job, to find the blue stuff. Okay. So the first thing we're going to notice is that the sum of the angles of a triangle always add to 180 degrees. So what we should make a note of is that angle A plus angle B plus angle C will add to 180 degrees. If we were working in radians, they would add to pi radians. Okay, so if I want to figure out what angle C is, well, we can just take 180 degrees. We could subtract angle A and subtract angle B. Essentially, I'm just solving for angle C here. So I'm subtracting angle A, subtracting angle B. So angle C is going to be 180 degrees minus 37.5 degrees minus 28.1 degrees. So let's figure out what this is. So 180 minus 37.5 minus 28.1. So I am getting, oh, need to redo that, sorry, 180 minus 37.5 minus 28.1. So I'm getting 114.4 degrees. Sweet. Okay, so let's record that. We just figured out that this angle right here is 114.4 degrees. Beautiful. Degrees. Okay, sweet. All right, so the next thing we need to figure out is we just need to figure out side length B and side length C. Okay, so for right now, let's see if we can try to find side length B here. Okay, well, if we're using the law of sines, what we would have to have here is that B. Now we want to divide that by the sine of angle B, so that would be sine of angle B, which is 28.1 degrees. Okay, now I could set that up with the ratio of C over the angle C, or set that equal to A over sine of angle A. Now, I don't want to set this up with C over the sine of 114.4 degrees. I can't set this up right now because I don't know what side length C is yet. So I want to set this up using A's instead. So I want to set this up with side length A, which is 17, all over the sine. We know angle A is 37.5 degrees. Okay. Now we could easily solve for B by multiplying both sides by the sine of 28.1 degrees. So this is implying that B is going to be equal to 17 times the sine of 28.1 degrees all over the sine of 37.5 degrees. So all I did is I multiplied both sides by the sine of 28 degrees. If this is throwing you off while I put the sine of 28.1 degrees in the numerator, it means the same as me writing, this is the same as me just writing 17 over the sine of 37.5 degrees, and I'm just multiplying this by the sine of 28.1 degrees, and I just multiplied, think of this as over 1, I just multiplied it into the numerator. So either way. Okay, so let's see what we get here. So 17 times the sine of 28.1 divided by the sine of 37.5. Okay. I should also make a note here that make sure that you're working in degree mode. I should have verified, or I should have said that before, but I'm working in degrees here, so make sure your calculator is in degree mode. Okay, so I'm getting, for B, I'm getting a 13.153, 2 if I was going out to 4 decimal places. If I'm going to 3 decimal places, since 2 is less than 5, I'll just do 13.153. So this is roughly what B is if I want to round to 3 decimal places. So side length B here, this is 13.153. Awesome. Okay. So now we could figure out side length C here. So notice here that I could say that C over the sine of 114.4 degrees. Okay, this is going to be equal to, well, I could set this up as either side length B over the sine of angle B, or I could set this up with side length A over the sine of angle A. Now, either should work, but since I rounded this B value here, I'm going to actually work with A since I know it's exact. I'll show you, we're going to get the same answer either way. I'm just a little bit paranoid with accuracy. So 17 over the sine of 37.5 degrees. Okay, so C is going to be equal to 17 over the sine of 37.5 degrees times the sine of 114.4 degrees. Okay, so now this is just a calculator exercise. So let's see what we get. We get 17 divided by the sine of 37.5 times the sine of 114.4. So I'm getting that C is approximately equal to 25.4313 for rounding to 3 decimal places, 25.431. And there we have it. So this is 25.431. Beautiful. All right, so just for fun here, we're actually finished. This is the entire problem. We were given 2 angles and a side, and we found the other 2 sides and the other angle. So we've completed this triangle. I'd like to note here that we could have found C differently. So instead of doing 17 over the sine of 37.5 degrees, we could have also said that this is 13.153 all over instead the sine of 28.1 degrees if I want to use side length B over the sine of angle B. Okay, so now this will change the problem. We'll have a multiplying both sides by the sine of 114.4 degrees. So now I'll just have a 13.153, and I'll then have the sine of 28.1 degrees. So let's plug this in our calculator. We should get the same answer. 13.153 times the sine of 114.4 divided by the sine of 28.1. Okay, yeah, I'm getting the same thing. We're getting 25.431 if we're rounding to 3 decimal places. So we got the same answer. Beautiful. Okay. So I didn't say it from the beginning, but notice that what type of triangle this is. Notice I didn't even really think about, is this an ASA, this type of triangle. I really just said, hey, what pieces do I have, and how can I use the law of sines to make this work? But notice that right from the beginning, when we drew this triangle, this will be what type of triangle would this be? Well, this would be, I know a side, and I know 2 angles, but I don't know the side in between the 2 angles. So this was an SAA triangle. Let's do one more. Okay, let's say that we're told that angle A is 102 degrees. Let's say we're also told that angle C is 50 degrees. And let's say that we're told that length B is 89. Go ahead and pause the video and see if you can complete this triangle on your own. Okay, let's do it. First thing I'm going to do is I'm going to try to draw a sketch of this. Okay, so let's draw angle A. The first thing I'm going to notice here is that angle A is bigger than 90 degrees. This is an obtuse angle. So I'm going to draw the obtuse angle here. So this is 102 degrees. So this is angle A. Okay. So let's see. It told us what side length B is. Okay, so let's draw the other pieces. So let's draw this line to connect. This is going to be angle B. This will be angle C. What else has it told us? It told us angle C. It told us that this angle here is 50 degrees. 50 degrees. Okay. And here's angle B. We don't know what angle B is. This is a piece we need to figure out. But we do know what side length B is. We know that this length here is 89. We don't know what side length A is, and we don't know what side length C is. Okay, so right off the bat, let's just think about what type of triangle this is. Again, usually you don't have to always think about this, but it's nice to. I know 2 angles, and I know the side in between the angles. So this is an angle, side, angle triangle. But regardless, I know 2 angles. I could find the third angle. I could use the law of sines to solve the rest. So let's first find angle B. Angle B is going to be 180 degrees minus 102 degrees minus 50 degrees. So let's see what this will be. This will be 180 minus 102 minus 50. So I'm getting that angle B is 28 degrees. Sweet. Okay, so we know one of the angles. Okay. Let's try to find one of the sides here. Okay, let's say that, does it really matter which one we find first? I don't know. Let's try to find angle A first, side length A. So if I'm trying to find side length A, this would be A over the sine of 102 degrees. Now I'm going to need to set this up. I would need to know a side length and the angle. Okay, so I don't want to use C divided by the sine of 50 degrees because I don't know what C is. But I do know what B is. So this, I'm going to set it up with 89 all over the sine of 28 degrees. So solving for A is going to be equal to 89 over the sine of 28 degrees all times the sine of 102 degrees. Okay, let's see what we get. So 89 divided by the sine of 28. Okay, times the sine of 102. So I'm getting that A is approximately equal to, I'm getting 185.432. So we have this length here is approximately equal to 185.432. Beautiful. Okay, let's try to find side length C. Okay, we're trying to find side length C here. We would have C over the sine of 50 degrees. Okay, we could work with A or B here. I'm going to work with B again because I know 89 is exact here. So 89 all over the sine of 28 degrees. So we'll have C will be equal to 89 all over the sine of 28 degrees. I'm just multiplying both sides here by sine of 50 degrees. Okay, so let's see what we get here. C is going to be equal to, we get 89 times the sine of 50 divided by the sine of 28. So I'm getting that C is approximately equal to 145.2227 or 223. So here is side length C. We have 145.223 and we're finished. This is the completed triangle. Okay. I hope you enjoyed this video. What we're going to be doing in the next video is we're going to be trying to solve SAA triangles using the law of sines. This will be the ambiguous case. We're going to always need to be careful with the SSA triangle or the ASS triangle. We're going to be careful. Okay. We'll see you then. Take care.